For this question, we want to use the graph of y equals 3 to the x and transformations to sketch the exponential function below, f of x equals 3 to the negative x plus 3. In addition, we want to determine the domain and the range, and the y-intercept and the equation of the horizontal asymptote. So I'm going to start by taking a look at the graph of y equals 3 to the x. We're going to sketch the graph of y equals 3 to the x by plotting points. I'm going to choose a standard set of x's, -2, -1, 0, 1, and 2, and we're going to substitute it into that equation y equals 3 to the x. So let's start down here with the easy ones. 3 to the first power is 3. 3 to the second power is 9. 3 to the 0 power is 1. 3 to the -1 power. Having a negative in the exponent means reciprocal of the base. So the reciprocal of 3 is 1/3. And the power is a 1, so that's 1/3. And we'll do the same thing here. 3 to the -2. Having a negative exponent means reciprocal of the base. That's 1/3 squared, which is 1/9. So this gives us a set of ordered pairs, -2 and 1/9, -1 and 1/3, 0, 1, 1, 3, and 2, 9. And we can get a good sketch of the graph with these 5 points. So -2 and 1/9 would be really close to 0 for the y part, -1 and 1/3, and 0, 1, 1, 3, and 2, 9. These points connect with each other in a very smooth curve, and we can follow the pattern of what's happening. So if we continue to choose larger x values, the y values become larger. And on the left-hand side, if we continue to choose negative x values, then our y values will continue to get closer and closer to a y value of 0. So for this function, we have a horizontal asymptote that's falling right on top of the x-axis, and that is the line y equals 0. So this is considered our base graph of y equals 3 to the x, and we want to use that information to help us draw the graph of f of x equals 3 to the -x plus 3. So we're going to graph that function with the idea of transformations. So we're taking a look at the function f of x equals -x. Let me write it out here. F of x equals -x, 3 to the -x plus 3. So we identify the base graph as being 3 to the x power. That's the function that we just drew. Y equals 3 to the x. We want to keep in mind that we have a graph that's increasing and that horizontal asymptote right on top of the x-axis. That's going to be very helpful when we try to graph with transformations shortly. So we have two transformations in this function. We have a negative and a plus 3. We have a negative and a plus 3. So the negative, multiplying by a negative, is the transformation of reflection. And there are two types of reflection, a vertical reflection and a horizontal reflection. When you have a negative that's multiplied onto the x part, that's on the inside of your base, that is a horizontal reflection. So this is horizontal. If the negative would have been here, this negative is on the outside of the base function, and that would be a vertical reflection. The plus 3 is a shift. When you add and subtract onto your base, you have shifts, and you could have a vertical shift or a horizontal shift. And because this is adding out on the outside, adding to the overall base, this is a vertical shift. And because it's a plus, it's going to shift up. So this is going to help us draw the graph. I'm going to try to zoom in so my graph isn't so small here. So we're going to take these points, and we want all of these ordered pairs that are on the base graph, we want to reflect horizontally and then shift up vertically. When we reflect horizontally, that's affecting the x, and when we shift up, that's affecting the y. So when we think about these ordered pairs that we have, the reflection will change only the x coordinate, and it's going to change it by being the opposite. And then the second transformation will only affect the y, and it will add 3 to those coordinates. So I'm thinking of those ordered pairs that we have. -2 and 1/9, that point will change the x to the opposite, +2, and the y, we're going to add 3, so it'll be 3 and 1/9. The point -1 1/3 will have the opposite x and add 3, so 1/3 plus 3, 3 and 1/3. So that's what it will transform to. The point 0, 1, well, the x is 0, the opposite of 0 is still 0, and if you add 3 to 1, you get 4, so that point will move to 0, 4. The point 1, 3 will become the opposite x, and add 3 to 3, and you get 6. And then the point 2, 9 will be -2, the opposite x, and add 3 to get 12. So if we keep those points in mind, in addition, the horizontal asymptote is at 0. We're going to shift that up 3, so it's going to move to be at y equals 3. And so we get a new graph that looks something like this. -2 and 3 and 1/9. Oh, that's a +2. And 3 and 1/9 would be about right here. +1, 3 and 1/3 would be about here. 0, 4, and -1, 6, and -2, 12. So we get this picture. Let's zoom out so we can see the base graph and this transformed graph. So you can see the graph is horizontally reflected. So what's on the left becomes the right, and what's on the right becomes the left. And then shifted up 3, so the entire graph is shifted up to this line right here. So we have the new graph, and we have a couple more questions about this. Let me zoom out to the directions. And in the directions, we want to find the domain and range. The domain of every exponential is all real numbers. The range, because we've shifted up 3, becomes 3 to infinity. We've already noticed that the horizontal asymptote is y equals 3 because it was shifted up 3. And you can do the calculation for the y-intercept, but it is 0, 4. So let's do the calculation. Our function is 3 to the negative x plus 3. If we're looking for a y-intercept, we let x equal 0. And that's f of 0 equals 3 to the negative 0 plus 3. Negative 0 is 0. 3 to the 0 is 1. And 1 plus 3 is 4. And so we get the ordered pair 0, 4 being the y-intercept. Thank you for checking out my videos. Have a great day.